All right, guys, today we're going to be talking about the rate of change as well as looking at some linear graphs. So, few quick reminders. This should be fresh. Y'all know this stuff, but we're just going to bring up some stuff that we haven't talked about in a little while. One thing, super fresh, y'all do it on your brain dump all the time, is all the ways that we can refer to slope. We can call it the rise over the run. We can call it the letter M. When we're dealing with word problems, a lot of times we call it the rate of change. We can refer to it as the change in y over change in x. And this one we usually use with tables, but this one is very important for labeling. If we're talking about the distance someone travels over time, the distance traveled, let's say miles, would be your y. The time, let's say hours, would be your x. So if we were looking at a graph, that might look like time or hours, miles, or distance. And the change in y, the change in y over the change in x is going to give you your label, okay? So this is important. The y over the x, the miles per hour. So change in y over change in x can help with the labels as well, okay? So let's just do some quick reminders. When we are given a graph, if we are asked to find the slope of a graph, we use rise over run. So we're going to start at the lower point. We're going to create a right triangle that attaches the higher point to the lower point. We're going to rise so that we went up 1 unit. And we're going to run 1, 2, 3. And because we ran to the left, that's going to be negative. So my slope is going to be negative 1 over 3. Negative 1 over 3. Rise 1, run 3 to the left. If you run to the right, it's going to be positive. A very important note here. Watch the intervals. The intervals are what is counting by. So if it's just grids, then that's just going to be counting by ones. But this could be counting by 10, and this could be counting by 3s, or whatever. Watch your intervals, very important. With a graph, we use rise over run to find the slope of the line. If we are given 2 points, we have been using m equals y2 minus y1 over x2 minus x1. We label our points x1, y1, x2, y2, and we plug it all in. y2 is 4 minus y1 is 1 over x2 is 3 minus x1, 0. 4 minus 1 is 3. 3 minus 3 is 0. The slope of our line is 1. Given 2 points, we can use the slope formula, which is y2 minus y1 over x2 minus x1. Plug the numbers in and solve to get our slope. It is very important that you're familiar with how to use this formula. You're also familiar with, and this is also very important, how to do it on the calculator. But this process is important because you can be asked questions about what steps next, or what should be plugged in where, or is this set up correctly, or so-and-so set it up this way. Where did they go wrong? So if you only know the process of plugging it into the calculator, you'll be able to answer some of the questions, but there will be questions about this process, so it's important that you're able to use slope formula correctly. Okay, let's practice the calculator process with the table. We know that with the table we can use change in y over change in x, and we'll do that as well. Change in y, 8 minus 4 is 4. 12 minus 8 is 4. So my change in y is 4. 2 minus 1 is 1. 3 minus 2 is 1. So my slope is 4 over 1. Or 4, change in y over change in x. But let's practice it on the calculator, okay? So we're going to find the slope of this table using the calculator. Very important, and this is something that you do write down on your brain dump, so don't forget to reference that and know how to use it. We're going to go stat, edit is going to be highlighted, and we're going to hit enter. At the top, it should say L1, L2. Is that better? If there's stuff in there, go up, clear, down. Do not use delete. Then I'm going to go over to my L2, up, clear, down. All right, I'm just going to type my table in. My X's will always go in the L1, 1, 2, 3. My Y's will always go into L2, 4, 8, 12. If you ever get into this screen and something looks funky, reset your calculator. Second plus 712, also on your brain dump. I got it in there. I make sure they line up. I make sure they match my table. I go back to stat. Stat, over to calc, down to linear regression. We know this is linear because the change in y over the change in x was constant. 4 over 1, 4 over 1. It was the same in every spot. I hit enter a bunch of times, and I find that the equation of the line is y equals 4x plus 0. That tells me that my slope is 4, my y-intercept is 0. This process can be used even when you only are given 2 points. Because if I'm given 2 points, I can easily make a table out of that, right? A table is a list of points. So I could make this 0, 1, 3, 4. This would be a great opportunity to check yourself. Make sure you got it right. A great way to do it. Stat edit, clear out what's in there, and I'm going to type my table in. 0, 3, 1, 4. I definitely recommend writing it as a table before you try to plug it into your calculator, just to be certain that you get the X's in the right column and the Y's in the right column. So that was stat calc. I got it entered. That was stat edit. Got it entered. Stat calc, linear regression, and I can see that my slope is 1, and I also found my y-intercept of 1. So if you need to write the equation of a line, you need to find the slope of a line, or you need to find the y-intercept of a line, use your calculator. As long as you are given 2 points or more, you can use that method. You could have used it on the graphing one too. Although rise over run's pretty straightforward, you could find this point, which I'm over 1, 2, 3, up 0, so 3, 0. This point over 0, up 1. I could use those 2 points and plug it into my calculator as well. Okay? Let's talk for a real quick minute about intercepts. Intercepts are the point where the line crosses the axis. We know that this is our x-axis and this is our y-axis, right? So the point where the line crosses the x-axis is my x-intercept. The point where the line crosses the y-axis is my y-intercept. Really important thing to remember. If I am going to my y-intercept, I need to be at my y-intercept. I do not move left or right. So at the y-intercept, x equals 0, always. So your y-intercept will be written 0, comma, whatever number, wherever it is. So this one would be 0, comma, 3. X is always 0 at the y-intercept. And then at the x-intercept, y is always going to be 0 because I cannot move up or down at all if I'm going to be on the x-axis. So my x-intercept will always be written some number, whatever the x value is, comma, 0. That's important to note because let's say you had some equation in your calculator. Let's say you were looking at the equation, I'm just going to make one up, y equals 1/2 x minus 3. Okay, so I go to my y equals and I type in 1/2 x minus 3. And I go to my table. if I understand that x is always 0 at my y-intercept, then I can look at the table and I can see, okay, here's my y-intercept. And if I'm looking for where y is 0, I can find my x-intercept. So that's important. You may also be given an equation, maybe not in slope-intercept form, and asked to find the intercepts. So let's just do one of those. Let's say I had 2x plus 4y equals 8. And they said, find the intercepts. Well, because I know that x equals 0 at the y-intercept, I can plug in 0 for x and solve for y. So 2 plus 4y equals 8. I subtract 2 from both sides. I end up with 4y equals 6. I divide by 4, and I see that y is at 3/2. What that means is the y-intercept can be found at the point 0, 3/2. 0 for x, 3/2 for y. The same thing can be done, or the opposite thing can be done to find the x-intercept. I can plug in 0 for y and solve for x to find the x-intercept. So an important piece of information that you need to understand and understand how to use is that at the x-intercept, y is always 0. At the y-intercept, x is always 0. Okay? You will be working some with intercepts today and even just locating them looking at a graph. To do that, we look for the point where the line crosses the axis. All right? One last thing is just discussing the way things can be asked for. You may be asked, what was the initial amount, or what was the starting point, or where on the graph represents when this began. Anything about the starting point, they're referencing the y-intercept. Okay? If I start with $500 on my graph, that's going to look like 500 here at the y-intercept. Okay? So anything about the starting point, the initial amount, where it began, those kind of things are referring to your y-intercept. And we know in our y equals mx plus b slope form of a line, b is the y-intercept. Okay? And then for slope, as we discussed at the beginning, a lot of times when you're dealing with word problems, is going to be referred to as the rate of change. At what rate is this changing? That would be the rate of change. So understand the vocabulary so you know what to be looking for.